The swing up and balancing of a double pendulum on a card is a challenging control task, which requires in general a high level of expert and system knowledge. In this demonstration, we are using the reinforcement learning method PILCO to learn the swing up and balancing of a real double pendulum on a card from scratch, without the use of any specific expert knowledge. In order to assure a high data efficiency, learning takes place stepwise. Based on the recorded data after each iteration, the dynamic system behavior and an appropriate controller are learned autonomously. The method is initialized with a random control signal on the card. Learning the system behavior of the double pendulum is particularly difficult since it is a highly nonlinear, chaotic system. After the 14th iteration, the upper unstable equilibrium is reached for the first time, however not stabilized yet. Further data around the target state are necessary in order to also achieve the balancing task. After a total interaction time of 88 seconds, the learned control strategy quickly achieves the upper equilibrium and can be stabilized. The control task was successfully solved without any prior expert knowledge.